Okay, sure. You can see the screen again even now. Okay. So we're gonna do that example on page 50. I'll just write the page number here. Page 50. I'll just write it's example 2.5. Okay. Yeah, that's the one that we're gonna be doing. Do you see that example there? Okay, sure. Let me just do this. I'll show you that there's a two ways. There's two ways to solve this problem. I'll show you how. This is our theta, and then p equals to 200. So let me introduce you to this. This is what we call the components. When they say components, what they mean by components, your components, it's your x or your horizontal axis. Okay, that's the first one. From a Cartesian plane, remember, you've got the x-axis and the y-axis. So that's what they mean by the components. So there's your x, there's your y. So now, or it can be your y or your vertical axis. So basically, when they say find the components, it means you'll be given the resultant. You'll be given oh sorry. You'll be given resultant R. So remember, previously we had something like this. You're given the components x and y, and you're required to find yes, and you're required to the resultant yes. But in this case, this and this are not given, so now you have to find them. That's the question. That's the question. Do you get that? Okay, sure, sure. So now let me just do this. Please wait. So do you have before we can do anything? Do you have any question from the previous session maybe, or the question that you came across? Okay, no, not a problem. Then if you've got any question, you let me know, ne? Okay. Um, let me get back to the presentation and let's work. Okay, where is that pen? Oh, yeah. Okay, so with this one, then like I said, we are required to find this. We are required to find this. There's your, let's just name it y. Let's just name this one x. Or let's do this. Because we are using p, we can say this is our p y, this is our px. So having said that, since here we are required to find the y and the x axis, here's what you're gonna do. Remember, to find the resultant, what were you using? We were using SOHCAHTOA. You see, as you can see, this is a right angle triangle. Do you see that? If you transfer, this side, remember I said you must keep what do you call it, x axis as a reference. Yes, so if you transfer, let's just do that. if you transfer this y-axis to this side, then as you can see, they must go away from the pivot point. Remember, this is your py, this is your px. This is how you transfer. As you can see, this is a 90-degree angle there. So this is a right angle triangle. So for a right angle triangle, you can use SOHCAHTOA. So we can use SOHCAHTOA and Pythagoras theorem. So in this case, we are only given r. So you cannot use Pythagoras theorem since you are only given r. Remember, Pythagoras theorems requires at least two sides to find your third side. So now, since you are given the angle, this theta, since you are given the angle theta, you have to choose the formula that you can use to find your py or your px. So now, which one can we use? You can use this one. I normally start with this one because it's opposite to that angle. So now you go. Remember, you're given hypotenuse. This is your hypotenuse, right? This r. So it means you can use either this one or this one, but then you need to confirm which formula I can use. Which one can you use to find py? Yes, because the angle is opposite to that. Yes. So you're gonna say sine theta equals to opposite, which is your py over h. And then to find the px, just because as you can see, there's no opposite for px. There's no opposite, as you can see. So you're gonna have for px there's no opposite. So you're gonna have to use cos. Do you see that? Is there's nothing. There's no angle. So you're gonna say cos theta equals to p x over h. Yes. So and another there's alternative formula that you can use. I want to just do the introduction. We'll do the application now. So whatever that I just wrote here. Remember h. This h. Let me just write this instead of writing h. Let me just write p. You know p. H is p, right? Yes. So you can just write p there to be formal. Let's just write p instead of h. Okay. So this problem, it can be written like this. We'll get to that. For sure you've seen something like this in your prescribed book. You see, for sure you saw something like this. For sure you saw something like this. If this one is p, if this one is p is equals to 200, I'm gonna do the same example. Instead of writing that theta, it's cost. Yeah, you see these people that are looting now. The guns are, I can hear the gunshot. Yeah. So let's write p equals to 200 somewhere here. 200 newtons, I think. Yes, newtons. So now, if you find something like this, Bafo, this is a small right angle triangle. As you can see, it's inside. It's a small right angle triangle. Do you see that? So this simply means, you see that 30 degrees. Instead of writing 30 degrees, you can write this in the form of the minor right angle triangle. So you're gonna have to say, to find the values for this, I'm just showing you for interest sake. I'll show you. You'll see the applications when we get there. To find the values of this, you're gonna say tan theta, which is 30 degrees, okay, equals to tan is what is opposite over adjacent, or you can say sine 30 degrees equals to let me remove this, equals to what is it? Opposite over hypotenuse. It's equals to opposite. Remember, whatever that I'm doing now, the reason why I'm using the angle, so it's for your minor right angle triangle. The values that I'm gonna get here, it's for your minor right angle triangle. So and then cos 30 degrees equals to adjacent over hypotenuse. So the values that I'm gonna get here, these are the values. You'll see something, it'll be common. Your hypotenuse and your adjacent will be common. You'll see that. Let's say tan 30. Tan 30, you'll get root 3 over 3. Okay. Root 3 over 3. So this root 3, it's for opposite. You'll write it here. And then that 3 is adjacent. You'll write it down here. This is your adjacent. Then your hypotenuse, we need to find one of them. We can use sine. You can say sine is equals to 30 sine 30. Okay. Sine 30 equals to sine 30 equals to opposite over adjacent. So now look at this. Do you agree that to find r, just for interest sake, to find r, you can find it this way. Just because you use tan, I normally use tan alone, but then you can use even sine and cos. I normally use tan alone. Then to find r, you need to use Pythagoras theorem. So you can say root 3 squared plus 3 squared. Then you find your value of r there. That's how you'll see your r for sine and for cos, it will be the same. So we can say root 3 squared plus, I'm just doing the introduction about for right now. You will see the applications when we get there. So I got 2 root 3. If you go and say sine is equals to opposite over hypotenuse. So if you punch those values of opposite over hypotenuse, you'll see you'll get the same value. Sine 30 is equals to 0.5 2 root 3. Okay, it's 1 over 2. So your hypotenuse, in this case, they're saying it's 1 over 2. Do you know why when you say sine 30, you get 1 over 2? It's because of, if you put opposite there, if you put root 3 here, root 3 over your hypotenuse, your hypotenuse is 2 root 3. So this root 3 and root 3 will cancel. That's why you get 1 over 2. Do you see that? Yeah, that's why. So the best trick is to leave this one out. I'm just showing you that sine 30, I'm just showing you that sine 30 can be written, instead of writing sine theta, you can write 1 over 2. You'll see the applications when we get there. Let me just finish up the introduction. Then you say cos 30, it's root 3 over 2. Root 3, ish, root 3 over 2. It's root 3 over 2. So you can, instead of writing cos 30, you can write it as root 3 over 2. Do you agree? Instead of writing cos 30, instead of writing cos 30, you can write root 3 over 2. Cos 30 is equals to, yes, you'll get the same answer. You'll get the same answer. It's adjacent, which is 3 over hypotenuse, which is 2 root 3. you'll get root 2. Yeah, you'll get the same answer. You should get the same answer. 3 over 2 root 3. Yeah, yeah, it's the same answer. Do you see that? Okay, sure. Let's just start with the first one. Let's just finish that example. Example 2.5. There. Because I want us to try and finish this chapter today, bruv. I want us to push this chapter today. Finish everything. Because we need to push those the chapters for assignment. We need to push those chapters. Chapter 8 and chapter 6. Is it 6? No, 7, 8, 9. Those are the chapters that you're gonna find on the assignment. Yeah, so we need to try and push those ones, so that it will be easier to do the assignment. So this is your px, is your py, all going out. Okay, so to find these values, like we said, you're gonna use SOHCAHTOA. So let's just do that. Then we're gonna say sine 30 degrees, sine 30 equals to opposite, which is your py over p, which is 200. So you're gonna make py the subject of the formula there. Then you're gonna say 200 times sine 30 is equal to 100 newtons. So py can be found if, let's say, it was a minor right angle triangle. If you had a minor right angle triangle instead of the angle, then you're gonna write those values here. Just use tan. I normally use tan, and then I normally use tan 30 to find my opposite of adjacent. Then from there I find r, the small, for the minor right angle triangle. You get my point? Yeah, that's what I do. I use tan. So then to find your px, you're gonna say cos px over 200, your py, sorry, px, ish, this thing, your px, you're gonna punch it on the calculator. And remember you have to put your calculator in degree mode, right? So you're gonna get 173.2, 173.2 newtons. That's your answer. Let's find those answers. I'll show you using the minor right angle triangle. I'll just write those values. P equals to 200. You'll see you'll get the same answers. In this case, you are given the two values. It's root 3. They will say this is root 3, and then this is your 3. The first thing first, you're gonna have to find your r. They normally give you these two values. Then when you find your r, you saw how we found our r. It was 2 root 3. So our r is 2 root 3. Ne? Sure. So now we need to find the components here as well. We need to find these values using the minor right angle triangle. So this is our px, this is our py. Will you agree with me if I say, okay, instead of writing sine 30, because in this case we are not using sine 30, I can write, since sine is opposite, I can write opposite, which is root 3, over hypotenuse, which is 2 root 3. And then instead of writing cos 30 or cos theta, let's just say cos theta, we can write, we use the minor right angle triangle. Here we got root 2, 3. So instead of writing that cos 30 and what, we are not given the angle that 30, we are not given that 30. So now we need to use the minor right angle triangle. So I can say cos theta, which is 30 cos 30, is equals to adjacent. What is my adjacent for minor right angle triangle? Is 3. Then hypotenuse is 2 root 3. Yes. So where there is cos theta, I'm gonna put this. Yeah, and then where this sine theta, I'm gonna put this. So now let's go ahead and use that SOHCAHTOA. So we're gonna say py over 200 equals to no, I cannot say py. Wait, let me do this. Okay, let me just erase everything. So I'm gonna say okay, yeah, I'm right. Py equals to over 200 equals to sine. Remember, for py you're gonna use sine. So instead of writing those sine theta, you can say it's equals to sine theta. Then you know sine theta equals to root 3 over 2 root 3. So now you have to make py the subject to the formula. So py equals to 200 times, you have to multiply by that, times root 3 over 2 root 3. I think you should get the same answer. Half of 200 is 100. Remember, that root 3 and root 3 will cancel. So half of 200 is 100. This and this will cancel. Okay. And then to find px, you're going to say px over. Okay. To find px, you're going to say, you're going to use cos theta equals to uh, adjacent over hypotenuse, which is your 200. Then instead of writing cos theta, you're going to say, what is cos theta? Cos theta is equals to adjacent. What is your adjacent in the minor right angle triangle? Is 3 over hypotenuse, which is root 2, 3. Then to find px, you're gonna say px equals to, oh, this one is 100 newtons. And then here you're gonna say 200 times 3 root 2 root 3. You shall get that answer there. 3 2 root 3. Yeah, you got it. 173.2. Sure. Do you see the difference? Okay. It's not that bad. It's not that bad. Do you have any question about up to so far? Okay. 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 In your uh you'll be given a question like this. You'll be given the minor right angle triangle. So normally they give you these values, only these two values, and then they also give you P, which is your resultant. They give you P as 200 newtons. So now they tell you to find this. The reason why I changed that 30 to minor right angle triangle is to show you that 30 can be written as that. Yeah. So now they will ask you to find the py and the px, the components. That's the next question that you are supposed to do. You see that example 2 2.6. Yeah, but in this case they used 4 and 3 because it's a different angle. So we did prove that this is the same. You get the same values, right? You get the same values. So if you if you're given something like this before, you're gonna have to find your r for your minor right angle triangle. You use the minor right angle triangle. Then we used Pythagoras theorem. We found 2 root 3, right? And then from there, we're gonna have to use SOHCAHTOA because it's a right angle triangle. You only use SOHCAHTOA for right angle triangle. So now you're gonna say SOHCAHTOA to find our PY. You're gonna say, as you can see, this is the same as then an angle. It means this whole thing, it means your theta, it's opposite. This angle here, it's opposite to this PY. Do you see that? So you're gonna say sine theta equals to, because you don't have the angle, that's why I'm writing theta there. So sine theta is equals to opposite over hypotenuse. This opposite over hypotenuse, sorry, this opposite over hypotenuse, it's for your minor right angle triangle. So now opposite over hypotenuse, you're gonna use your minor right angle triangle. Your opposite, it's 3 root 3. Then your hypotenuse is 2 root 3. They are saying sine theta equals to opposite over hypotenuse. Okay, wait. Let me do this. Let me do this. Sine theta is equals to opposite over hypotenuse. Opposite over hypotenuse. Okay. And then hypotenuse in this case, I made a mistake there. Uh, I made a mistake there. Sine theta. Remember, this hypotenuse. It's for your resultant basically. That p that p. Let me write p so that I don't get confused. Let me write p there. Sorry. Let me just write it like this. This side, I'm gonna do this. I'm gonna highlight it to you. This side is your minor, and then this side is your major right angle triangle. And I think in this way it will make sense. Sine theta, if we're given the angle, this angle, we're gonna say this theta, angle theta, it's opposite to P, your minor right angle triangle, your PY, right? So you're gonna write PY over P. Remember, we're given that sine theta. Remember that. But then in this case, we're not given angle theta. So instead of writing theta, sine theta, remember, this is your minor right angle triangle, the left hand side. This is your minor. So you're gonna use those values of minor. You're gonna say that's because we are not given that theta. We're gonna use the minor right angle triangle for the side of the theta, sine theta. I mean, you're gonna say opposite over hypotenuse, which is your what is your opposite for your minor right angle triangle? Your root 3 over 2 root 3. So we go back. Where there's sine theta, you're gonna replace that. You're gonna say root 3 over 2 root 3. What you need to know about is that just because you're not given that angle, instead of writing sine theta or sine 30, you're gonna write those values for the minor right angle triangle. Does it make sense now? Sure. Sure. Okay, so any other question before we can continue? Okay. So we covered that part. We covered that part. Um, you see, even your example 2.6, they used the same method. Uh, Example 2.6, they use the same method. You are given P equals to 200 newtons, and then here you've got 4, you're given 4 and 3. So first thing first, remember what I told you. If you want to find x and y, x and y components, first thing first, you're gonna have to project a dotted line going up away from that pivot point, away. This is a pivot point. So you name this your px, you name this your py. Then from there, first thing first, after doing that, just because it's a right angle triangle, you're gonna have to find what? You find your r, right? This r is, you wanna say root 3 squared plus 4 squared equals to, you'll get 5 here when you square it. Because it's 9 plus, you'll get 25. It's 9 plus 60. 9 plus 60 is 25. Root of 25 is 5. Sure. So we can, instead of writing r there, let's go back. We write 5. Sure. Then now let's find px. Px. We're gonna use soccer. Yeah, we're gonna use soccer toward there. So now, to find px, what are we gonna do? Adjacent, which is your px, over hypotenuse, which is your p. And then, since we are not given the cos theta, we don't know the angle theta, we're gonna use those values. What are we gonna put there? 3 over 5 equals to px over, okay, and then our px will be, you're gonna have to multiply there. You're gonna say 200 multiplied by 3 over 5, and then you'll get your answer there. 600 over 5. Sure, 120 newtons. And then if they want the direction, you just do this. You see it's going there, just do this. Or you can write positive. Remember, the direction matters as well. The sign, it affects your equation. You'll see why I say it affects your equation, because when you've got more than 2 resultants, it will affect your equations. Remember, second quadrant is negative, and then our first quadrant is positive, and the fourth quadrant is also positive. But then in the second quadrant and the third quadrant, it's negative. So you need to know the sign matters in this case. So to find our y, you're gonna say sine theta equals to py over p, which is equals to, with this sine theta, we're gonna put what? 4 over 5 equals to your, okay, 2 times 4, it's 800 over 5. 800 over 5, you'll get 160. Yeah? You get 160 newtons, and then it's going up. Or you can write it as positive from the Cartesian plane, is it's positive as well. Any other question, Bafo? Okay. Um, let's see, because I'm trying to push this whole chapter. I want us to finish this whole thing today, like even the exercises and everything. I want to try and finish this whole thing, and then we have to do moments as well. So let's try and push as much as we can. I'm just doing the examples. After the examples, we do the exercises. Then if we can still push, then we go. So now let's do that example 2.7. It looks complex. Let's see that. Remember, I do different examples, then from there I go to the exercises to do the applications of those examples that we did. Yeah, the examples, I'm just showing you how to solve them. I'm just briefing you. This one, it's like this. Then you've got this one, and then here you've got this one. Okay, let me just, oh, so here you've got the surface here that is crossing like this. Then you've got 60 degrees. Okay, and then you've got 40 here. Then you've got 70 here, but 70 is the whole thing. It means, do you agree that this angle is 30? If this is 70, this whole thing, it's 70. That angle, small angle, is. And then this other one, this theta, is what? Okay. Okay. When you add them, they should give you 180. So if it's 50, you're gonna say 180 equals to let's just say 70 plus 60 plus theta. Then you're gonna make theta the subject of the formula. So it's 70 plus 60, will get 130. 130 plus 50, yes, that's 50 degrees there. Okay. And then the question says find the components of Q force for system of A and B. Okay, so now do you see that this is an unright angle triangle? Yeah, this one is different. Remember what I said? The problems that we're doing, you have to choose one. Yeah, in this case, you complete a parallelogram. It's either you transfer it to that side or this side. It's up to you. So let's just do this. Um, it's up to you. It's up to you. Here you choose. It's 30 here, it's 50 here, it's 60, it's 40. So you can choose either one. So which one do you choose? Where do you want us to transfer the information? Right hand side. Okay. Then we're gonna have to transfer that one. Then we've got your A this side, right? Above. Yeah, because if you wanted to transfer B, you're gonna complete a parallelogram. You just take B there, and then it goes with its angle. So what's the angle here? The total angle. Oh, must I remind you? Remember what I said? The angle for side A is this one, right? If you take this whole thing here, it means you have got 40 there. Do you agree? And then what's the angle for this? This is the alternating angle for B. It's like this. This is 60. Then it means there's alternating angle that is 60. So this side is 60. Do you remember we did something like this? So what's the angle, total angle here? Let's say it's angle beta. Angle beta. What's the total angle for that side? Sure, it's 100 degrees. Remember I said it doesn't matter. This is your R. In this case, this is your R. Remember here you are given R. You have to find those values. Remember The previous examples that we did, you are required to find the resultant, the middle one. Yes, you see the difference. Yeah. So since you are given that, how can you find? Remember, use sign rule because you are given the angle. So now, which one can you find between A and B? You check what you are given. The side, yes. Which side can you find? You check the angle that you're given. Which angle can you use? Which angle are given that you can use? Obviously, the side, the R1 Q over sine 100 is there. But then I'm looking for the other side that you can find. Remember, in order for you to find the side, you check the angle that is opposite to that side. Because if you don't know the angle that is opposite to that side, you cannot find that side. So which side, which angle is known? Which other angle is known? Okay, so you're gonna say A over sine 50. And then we know, let me do this. We know theta, this Q is called to 100. So, so A equals to, you're gonna have to cross multiply there. 100. I got 77 point, yeah, 77.79. Yes, that's correct. That's what I got also. Then we write that LB. That's your unit. So if they ask you to show the direction, what's the angle for that A? Remember the angle was 40. It was like this, 40 here. If they want the direction, that's the direction for A. You write, remember what I told you, you have to write the angle, show the angle as well. It's when you write, even when you wrote your resultant, remember I showed you how to write the angle for resultant. So even for this one, if they want the direction, you show that angle 40. You see, it's very important to know those things. To know the alternating angle and the opposite angles. Yeah. So uh, now we know our side A. So how do we find our side B? Remember the angle of a right angle triangle. So the angles of a triangle, they add up to 180. Ne? And now you know. So now you know how many angles. You know two angles inside that triangle. So can't you find that angle that is opposite to B? If yeah, because yes, that's 30, correct. 30 degrees. And then that 30, you know how can the other way of finding that 30? I wanted you to see, to prove that it's 30. The other way of finding 30, do you agree that this is an alternating angle? If you take this like this, it's an alternating angle. So here it's 30. I just wanted to show you that. Yes, I just wanted to show you that. Okay, so since you know that that angle is 30, even if you don't know that angle, you can use, if you don't know that angle, you can use the cosine rule, but it will be long. It will be long. I wouldn't advise you to use the cosine rule. Rather, use what you're given because the cosine rule is long. You'll get the same answer, but then it's long. So you have to find the easiest method. So now Guide me. What are we gonna do? Obviously, Q. We're gonna use Q. Then what's the other? Okay. Then we're gonna say B equals to. We know this one is 100. Let me just write inside the brackets. It's 100. Then what is our B? Yeah, one. That's the answer that they got. 50.7 7 lb. Then you also the angle of B. You need to also show that the angle of B. Remember, yeah, it's 60. The angle of B is 60 degrees. Do you understand it, Buff? You see, that's exactly what they got there, but then we use the other side. Either way, for components, there's no difference. It's the same. Yeah, because even if you use this side, let me show you something. Even if you decide to use the left hand side, this angle right here, it will be 60. And then also you'll get 100 here. This angle for A is gonna be an alternating angle. It will be 40. So either way, you'll get the same answers. This one is different from the other ones where you're not given the resultant because the angle was different. Do you see that? Yeah, you can choose any side. You'll get the same answer. Now it makes sense why I told you to choose any side. Remember when we started these things, I told you to choose any answer, but then the angle will be different. Yeah. So now we're gonna have to move to the next one. Do you understand it well for this one? Okay. Let's see. Let me just find another example. Then we're gonna have to move. We are moving, but we are moving. We are moving. Uh, what is the other one? The next one we're gonna do the vectors. But then this one don't be a problem. We're gonna you see that theory. I'm gonna summarize it now. You see, we are on page 52. I'm gonna summarize that thing now for you. There's no need for you to go through those things. You see, right now you've got something like this. There's no need for you. I think yeah, it's better to know that it's vector addition. It's when you have got more than two resultants. When you've got more than two resultants. So this is your pivot point, this is your x-axis, this is your y-axis. So it's when you've got maybe more than one resultant. So it's when you've got something like this. You've got resultant one, R1, and then you've got resultant two. So now they want you to find the total resultant. I think we did something like this earlier on. Remember when we did the yes, we did something like this on page 46. We did something like this, but then that for that one we're using the angles. Remember, but then in this case we're not using the angles. You see, they replaced that angle with the minor right angle triangle. Instead of writing that angle theta, they wrote something like this because this is the same as gosh, this is the same as when you have r1 theta and then r2 theta 2 theta 1. This is the same, just that they replaced that by the minor right angle triangle. You see, we have covered a lot of things before already. That introduction that I did to you, it made sense why I did that. You see that? Yeah, now it makes sense why I did that. So now, remember, what did I say? If you have got more than two resultants, what are you gonna do? You're gonna find your RT, which is equals to R R1 plus R2. Then what is your R1? Ignore the minor right angle triangle for now. Ignore it. Just give me R1. Remember, R1 has got two. You're only given the resultant. R1 has got your R1 has got your RX1, which is this one, RX1, and your RX2, RY1. This is your components. Do you see that? And then this one. So you're gonna have to find your x-axis and add them. So you're gonna find your Rx. IR1 has got RX1 and RY1. And then R2 it has got RX2 and RY2. Do you agree? So now what are you gonna do to find R? Let's just say, oh, RT, it must be, okay, let's do this. RT must be your Y components. You're gonna use Pythagoras theorem here. It's gonna have to say, you're gonna have to say RY plus RX. So now you need to find the total RX. Let's just say RXT, RYT. RXT equals to, you're gonna have to add RX1 and RX2. And then RY, remember we did this, right? RT equals to RY1 plus RY2. I'm just rewinding. I'm just going back to those things. Just showing you. I'm just reminding you before. Yeah, before we can do the example. Just reminding you. Then, are we still together? Do you still remember that part? Okay. Okay. Then let's move. Let's move. Let's do that example. Example 2.8. Do you see that 2.8 that example 2.8 on page 53? Page 53. Okay. And then you're given, I'm not gonna draw the Cartesian plane, I'm just gonna write this. Okay, let me just use a different color and do this. Okay, so you're gonna have to find, here we are required to find the components. So let me just do this. You're given 3, 4, that 5 normally it's not given, you need to find it. Then you're given 12 and 5. So first thing first, let's just label this. This is your P equals to 20. Buffer is still there. Okay, Q equals to 26 newtons. So here you are required to find the components, your total resultant using those components. So what do we do first, Buffer? What's the first step? Yeah, this is our px, and then for This is for upper part. Then for the lower part, you're gonna have qx here. Do you agree? Yes. And they are both going to that direction. So basically, let's use a different color. Let's do this. This is our qx. Yellow, it's for our qx. Let me just write it there, that block. And then the orange one is for this one. Do you see that? Okay. And then up here, we're gonna have p, y. And then down here, we're gonna have q. We're gonna have qy. Okay. And then from there, what do you do? Okay, sine theta. Sine theta equals to py over p. Okay, which is equals to over 200. And then exactly, exactly, exactly. Yes. You see, the reason why I didn't write this 5, I wanted you to find it. You see, that is the same. There, they found 5 already. But then, when you've got a question, it's not given. That 5 is not given. Yes, you have to find it. Then also find the bottom one. You should get 30. For Q, you need to find R for Q. Is always find R first. Yes. So it's 30. So now we can work. Let's work. Three over 5. Okay. We're gonna write our answer here. Is it going to positive or negative? Okay. So it's 200. 200 over 5. Sorry. Over 5 times 3. Should get, it's 120. I got 8. No, it's not it's not 200 of, it's 20. I'm surprised. Then you'll get 60. You're gonna remove that 0. So it's 12. It's positive 12. You write that sign, positive 12, or and then it's going up. Yes. Okay. And then let's find the other one. Let's start with the upper parking. The upper part. Yeah. Okay. Cos theta. Yeah, 4 over 5. And then you'll get something. You say 4 Yes, that's correct. It's 16 newtons. Is it positive or negative? You need to consider that. Sure. Then it's going to that direction. Okay. So we are done. Let's do this. I'm gonna duplicate the slide and remove this. Okay. I'm gonna duplicate the slide and remove this. This is for the second part. I'll just write on top. We still have the first slide. I'll just say bottom. Then to this one, I'll say the top. Yes. Okay, so let's go to the bottom one. The bottom one is okay, qx over q equals to qx over 26 years. Then qx okay 5 over 13. That's correct. Yes, you should get 10. Is it negative or positive? Wait, before wait. Wait, I'm trying to check something. I'm trying to check something. Yeah, this is your second quad. This is your third quadrant. But if I look at this, this is wrong. You know why? Look at this. Remember what I told you. This this is wrong. This is wrong. Remember what I told you. Look at this. I said this py it can come to this side. Ne? Ne? It's opposite to that theta. This is your theta, right? Then same applies to this one. Just because I said don't move the x-axis, it means you can transfer this information to this side, right? And then this is your new qy. So this is your angle theta. The moment you transfer this on this side, in this case, I'll advise you to make it similar to that minor right angle triangle instead of transferring it to the top. Make it similar to that one. What I mean by that, as you can see, this minor right angle triangle is sitting like this. So make it similar to that. So you're just gonna take that qx and put it here to make it similar. You get my point? But then for the other questions, don't move it. But then in this case, you make it similar to that minor right angle triangle. because otherwise it will complicate your things. Even if you don't move your x, you'll have to transpose, you'll have to shift this thing, you'll have to shift this minor right angle triangle to look similar to that one. So let's say you chose this one. Actually, sorry. Let's say you chose the upper one. You want to transfer this information there. It means you're gonna have to transfer that information this side. So you're gonna have to do this. Then it changes your whole thing. You get my point? Yes. So instead of doing that, just do this. This is the simplest way. Then after doing that, let me remove this. You make it similar. After doing that, where will be your angle theta? Look at this one. Look at this theta. You see this theta, where is it? It should be here. This should be your theta. Because this is your QY. Theta is always opposite to your QY or your PY. It's always opposite like this. It's always opposite like this. You get my point? Do you understand why I'm saying you must write it like that? This is your theta here. For your minor right angle triangle, there is theta there. There is angle. This is your angle there. So it must be like that. And then for this one, let me just do it for in case if you get it on the second quadrant. For this one, you'll do the same. Your minor right angle triangle will be sitting like that, and then for this one, you'll do the same. Your minor right angle will be sitting like that. So angle theta will be here in this case. You see that? Yeah. And then for this one, your angle theta will be here because the way it's sitting, it matters. So then we have to go back and correct that. Okay, let's go back. Does it make sense, Baf? Yeah, you follow a minor right angle triangle. So now let's correct this. Let's correct this. Let's correct this. Okay, what is sine theta? Let's go back to that second, the bottom one. Look at that bottom one. Sine theta is what? Opposite. Mm, exactly. It's QY. You know it's opposite to that angle. It's QY over 26. So do you see that that angle matters as well? You take the direction of the minor right angle triangle. The way it's sitting, it affects your whole equation. You need to consider that, before. Please, hey. Otherwise, you're gonna make a mistake. So the way it's sitting, it matters. Yeah, I think that's the easiest way of memorizing this thing. There in your prescribed book, they explain it differently, but then I always give you the easier route. I always give you the easier route. You won't forget this one, Buff, obviously. You see, it's easy to memorize this one, that you follow your minor right angle triangle. And then the angle, obviously, remember what I said? The angle is always between the x-axis and your resultant. Remember that. For your minor right angle triangle, which one is your x-axis? Is this 12 here? So your angle is always between that x-axis and the resultant. Your resultant in this case is 13, you see? So that's why that angle is there. That's the easiest way to memorize it. Yeah. So QY over 26 equals to 5 over 13. Okay. And then QY will be, oh, sorry, let me just write it there. then you should get 10, I think. Is it positive or negative? This side. This side. What is the value of y? This side. Y it's negative this side, and then positive, and then negative this side. So it has to be negative because it's going downwards. You need to write that side there. So let's go to the q theta. The q. And then for x, qx, how do you find qx? Yes. Yes. Qx. And then qx over 26 will be equals to, okay, then this one will be positive. It will be going to that positive direction. Sure. Positive 24 newtons. You have to write newtons, and then it's going to that direction. So do you agree that we found our, okay, let's just write here our rx will be equals to our y will be equals to, remember we said rt equals to rx plus ry, yes. So our rx will be equals to qx plus px. This one will be qy plus py, then equals to, is we go to qx. What is our qx? Is positive 24. Then we go to our px. Our px was positive 16. Yes, positive 16 will be equals to, I think it should be 40, this one. Yeah, it's positive 14, eh? You write positive 40 newtons. It's going to which direction? To that direction, because it's a x-axis. It's x-axis. So now ry, you're gonna say qy. What is our qy? It's negative 10. Plus, you see I put that negative there. Then py is also 20. It's going upwards, which is positive 20. Equals to 20 minus 10, you'll get 10. Do you see that? And then it's going up because it's positive. So, Buffer, do you have any question before I move to the next slide? Okay. So we got something like this. The other one was going down, the other one was going up. So there's our Rx, there's our Ry. So for our Rx, what do we get for our Rx? Okay. Ry, it was 10. Yes. So you see that you can draw your right angle triangle there using those values, those two values. So remember, I wrote those directions for a reason. You see, ry is going ry is going up, man, not down. Ish, why am I doing? What am I doing? Sorry. S- ish. Ry is going upwards, then rx is going to that direction. Rx is equals to 40. newtons. So now from this, how can we find our RT? I'm just showing you using that thing. You can find our RT there. So it means yes. So you have to use theorem of Pythagoras. Yeah, you see, I told you. Remember, I told you that your hypotenuse is always bigger than everything. For right angle, it's 41.3. 41. 41.23. Okay. Then that's your angle theta there. Then you have to show it. You have to show it. That's your angle there. So to find that angle theta, you use. Remember, I told you use what you're given. You have to use tan. Remember what I told you. You have to use the reference ones. Not don't use r. Then this theta will prove will. Remember, I told you last week that if you use don't use r, use the values that you're given, and then that will prove these values will prove that your r is correct. Um. Okay. Wait. But what did you get as your? Okay, let's see. Oh, our r. Wait. Why is our our ry different from theirs? Qy. Yeah, no. Let's check ours. It cannot be 20. You see, it's wrong. Our py is wrong. There's no way it can be 20 here. You see that? There's no way it can be 20 there. Yeah, I see there's a mistake, man. Because you have to multiply that 20. You're gonna say 20 multiply by 3 over 5. Yeah, it's 12. You see that? Above. Do you see the mistake? We wrote that 20 as it is. We didn't multiply. Fit. Yeah, yeah, yeah. And this is the mistakes that you can make in the exam, fit, and then you'll get wrong. Like it means you have to consider everything. You have to make sure because we wrote 20 instead of 12, so it means we're gonna have to change everything. Where there's 20, we put 12. So there's 12 there. So it means you're gonna get 2 there. Yeah, yeah. You're gonna get 2. Is positive 2. Hey. So it means everything is gonna change. See, but for don't make that mistake. You need to be sure. Yeah, hey, because minor mistakes can, hey, it means everything is gonna be wrong. If you make that mistake, imagine you wrote the value there, but then you got the answer wrong. You wrote 20 multiplied by 3 over 5, but then you didn't cross multiply. Hey, yeah, yeah, it's a problem. You know what you're doing, but then you didn't type. You punched it wrong in the calculator. Hey, and then here we're gonna have to square that. It's 2 squared plus 40 squared. Then I got 40.0. 40, okay. It's 40.05. Okay, and then remember, tan theta equals to opposite over adjacent. What is our opposite? Our opposite is Rx over Ry. And then theta will be arc tan of 40 over 2. 87,14. 87,14 degrees. I don't know why did they get that value, but then they know. Wait, uh, no, I don't know. I don't know why did they get that value. No, 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 no. Opposite. No, but for no. No, 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 but for you made a mistake. You made a mistake. It's not 40 over 2. It's opposite. It's opposite over adjacent. Opposite, which is your Ry. Opposite is your Ry over Rx. Rx is your adjacent. This is your adjacent. This is your opposite. Okay, let me write it on top here. Let me write it here. I think it's better if you write it on top here. It's 12 newtons. And then you will see which one is opposite, which one is adjacent. So it's 2 over 40. Yeah, 2,86 degrees. Then you're going to write that angle here. Remember, I told you to use x as a reference to find the angle, like this. Yeah. Any question, Buff? Are you sure? Beside the mistakes that you are making now, when this thing is talking to you, but then you can make a mistake. You see that this thing is telling you that I want opposite over adjacent, and then I want you can the minor mistakes that you can make is it's not about you. It's like you know the answer, but then you make a mistake when writing the answer. We must consider those mistakes, Bafo, because hey, in the exam, there will be no one who watches the mistakes. Hmm. So I think we are almost done with that question. Yeah, you see now, you see that example on page 54. It has got, you see how many resultants it has. Yeah, but then you apply the same concept. So that nothing is different there. Nothing is different. It's like okay, let me use the black one. Yeah, it's like you need to know the only thing that matters there is the directions. It is the directions that you know that this side is negative, this side is positive, this side is positive, this side is negative for y for x. The direction, that's the only thing that matters there. So let's just draw that. Normally draw a Cartesian plane for always. It's simpler with the Cartesian plane. You just do this. And then this side we're using orange. So meaning we're gonna have something that is going away from that pivot point. Then also, let me erase this one. On the Cartesian plane, this side we're gonna have another one that is going to that direction. So this is our the set. Let's just label them. Okay. I'm gonna use different colors, Bafane, for three resultants. And then this one here we are using yellow. Then there's yellow that is going up here. Then there's yellow that is going there. You understand why I'm doing this, ne? Sure. Then let's use black for this one. Black is fine. Yeah, I've got blue. Okay. Let's erase. I'm gonna erase the black one. Blue. You've got yo yo yo. Okay. Okay. The blue one. Let's use the blue one. We are only given this one that is going that direction. Ne? Then what you do, you have to draw away from that pivot point, away from that pivot point. Do you see that? The initials ones that were given, I'm gonna write the values here. Let's just say this one is P, this one is Q, this one is Z. These are the ones that were given. So for this one, for Q, we are given 6 kips. We're given 6 kips. Then for P, we are given 10 kips. Then for Z, you are given 6.8. Yeah, I'll just write K. So now, this side, we're going to have to find QX and QY. Then this side, we're going to have to find PX and PY. Do you see? I even wrote that minus P minus Y. Do you see that? Yeah, already it tells you that your Z and your P, your ZY and your PY is going to be negative. So let me just write it nicely. Let me just remove this and write it nicely. This is your PX. This is your PY. This is your ZY. This is your ZX. Okay, let me. I'm gonna draw that minor right angle triangle and write those values. It's 1, 2. Please find R there, and then there's 7 and 4. Please find R there. Then there's 50 and 8. Please find R there. Okay. Then we're gonna decide which. This thing is not that difficult, but for do you see that, Mark? It just yeah, I just need to be careful, like with the signs and your values. That's all. So you always find your if you're given more than one resultant, you find your Rx and your Ry, and then you combine them. That's the trick about it. It's 1 squared. It's 1 plus 2 squared. So I got root 5, ne? For yes, for this one it's root 5. Then for the bottom one it's 4 squared plus 7 squared. I got root 65. Is it root 65? Then for this one it's 8 squared plus 15 squared. Then I got 17. Okay, so we're gonna have to decide. We're gonna have to start from the first quadrant. We move step by step. Let me do this. I'm gonna duplicate this 3 times. I'm gonna duplicate it 3 times because we're gonna use it 3 times. I'm gonna duplicate it. Let me just do it 4 times then. I think it's much better that way. Okay, so now let's go here. Let's start with let me just highlight it. This part that we're gonna start with, we're gonna start with Q. Q values. First quadrant. So first quadrant, let's find x and y. Remember what I said with the minor right angle triangle? It tells you that this is your theta here. Then this tells you that this is your theta here. Then this tells you that this is your theta here. Do you see that? Okay. Then let's find our Q values. Sokato. First step, guide me. Tell me what to do. Sine theta equals to Qy over 6. Okay, and then Qy 1 over 2. I'm writing what you're telling me. I was gonna correct you when you get to the answer. That's what I do. I'm writing what you tell me. I'll correct you afterwards and show you, because if I tell you, it's like I'm not correcting you, so I have to leave you to do it the way. Then I'll show you after that you made a mistake here and here. And then Qy is equals to, is it positive or negative? Okay, then we write keeps. We write keeps there. Positive. And then let's go. What's the next one? Is cos. Cos theta. Yeah, Qx. Sure. Then you get your Qx there. 5,37 keeps positive, ne? Okay, sure. Then let's move to the second, to the this one, the third quadrant, which is our z. Sine theta zy 6,8. Okay, let me confirm that zy is equals to opposite, which is opposite to that angle. Okay, now that's correct. Okay, I agree. And then zy will, okay, opposite over hypotenuse. Yeah, that's correct. Yes, that's correct. It's negative because it's going down. Okay, so you said it's negative, -6. You just write keeps there, or can say downwards. Then your cos theta equals to obviously zx over 6.8. Okay, negative 0.2. Okay, it's fine. Then let's move to P. You see, this thing is simple, but it just, yeah, like the problem is that there's too much work. Like finding those values, it's too much, because after finding those values, you're gonna have to add them. After adding them, you're gonna have to find the RT. Mm, yeah, over 10. 4 over root is, because sine is equals to opposite. Is it negative or positive? Negative 4,96. Okay. Px over 10 is equals to Px equals to 8,68 positive, ne? Okay, so we are done. Whew. Now we have to be careful. For one, okay, let's do this. Now we have to be careful when we do these things. We have to be careful now with the signs. With the signs. So let's start with the, okay, let me skip this one. Go to this one. Let's start with the Rx is equals to Qx plus Zx plus Px equals to. So now we're gonna have to add all those values. We need to be careful now. And we need to be sure that all our values are correct. Otherwise, we're gonna have a problem. When you add those values and the signs as well, you have to put the signs as well. So now let's start, Buff. Let's start. Let's go. What is our okay? What is our QX? Now QX 5.37 positive, and then our ZX should be negative. Okay, let me see. It's negative. negative, let me see which one is it. I think it's this one. It's negative 3.2. Do you see that? Negative 3.2, 3.2. And then the next one is our px. No, 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 no. Okay. Our px is 8, positive 8.68. 8.68. Then we're gonna have to add these values. Okay, then we're gonna have to find ry. Ry equals to, okay, let me add. It's 5.37 minus 3.2, then plus 8.68. Did you get yes, that's correct. 10.85. That's what I got. 10.85, and then it's positive. What I got is positive, so it must go to that direction. You also got positive, ne? Okay, that's correct. Then we're gonna go to ry now. Ry, let's add those values. Let me go to here. Ry, it was 2.68. Okay, 2.68 positive. Okay, second slide. Okay, let me go to the third one. Ry is minus 6. Okay, minus 6. And then to the py minus 4.96. Minus 4.96. Ry equals to, okay, let's say 2.68 minus 6 minus 4.96. Then I got negative 8.28, yes, and then it's going downwards. So here to find our RT we use Pythagoras theorem. Do you agree? Okay, so you're gonna say 10.85 squared plus minus 8.28 squared. Then we find our RT there. Okay, let me. Then also you need to write the please write the units. But for if you don't write the units, it's wrong. Keeps. Then our RT is 13.6. 13.65 keeps. Then this one, obviously the direction of this one, you have to find it from there. From this, it's like this. The direction of this one, you have to find it using this. So it's gonna be like this. Ne? Do you see but for these things that are the tricks that I'm giving you, they are easy, ne? They are very easy. You see, even that example, they found the very same thing. Like now we need to find the angle using tan. That angle there. Yeah, we need to use that angle right there. So we need to use the values, those sides. So we're gonna say tan arctan of opposite. Our opposite it's minus 8 to 8 over 10.85. Then I got 37 point 34. Where is that pen? 30. Hey, how? How? I lost the pen. Oh wait, yeah, here is it. Bafo. Okay. Do you have any question? Tan theta equals to opposite, which is 8.28 over 10.85. That negative theta shows you that it's uh, in that negative, what do you call it? The direction of that thing. I mean, it shows you the direction. So here I got, what is that calculator? Got 37.345. 37.348. That's what I got in degrees. Do you understand it, Buffalo? Where? Hmm. Yes. Where? Which part? Where is that pen? I always. Where is? Which part? No, remember from the previous example what we did. This is your ry. This is your rx. So what is tan? Yes. And then from this is your theta. Remember what I told you? This is your theta. Your theta must be between x-axis and in your donkey. Then you're gonna transfer this information this side. So you're gonna have something like this. Sorry. Remember, I said you only follow the direction of that thing when you've got the minor right angle triangle. Remember what I said? Because the reason why I'm saying that it's because although if even if you do whatever that you are doing now, but then you're gonna have to transfer that information from the minor right angle triangle to the top part to the x-axis. You get the point why I'm saying you must use it as it is, leave it as it is instead of you transferring the information. So just because here we're not using minor right angle triangle, you can simply transfer that information. It's simpler that way. You use the simplest method but for to solve these things. Yeah, remember this is your ry, this is your rx. Remember how we found the previous one, like the previous example? We used tan as well from this one. We used tan. You see why we used tan? We transferred that information. But then if if we had something like this, let's say if we had something like this, it was gonna be different. Let's say this angle was given by 240 years, something like that. It was gonna be a bit difficult for us to choose this one, to choose the upper part, because of you need to transfer this information this side. So now for your minor rectangle triangle, you take it as it is. Then you do this. You get my point? Yeah. So always find that angle using tan. Remember, we agreed that you use the reference, you use the values that you are given. Don't use R. Don't use R. Sure. Does it make sense, Buff? I need to be sure that we are together. I see why you got confused. You know why? Because now this one, the right angle is in the third, the fourth quadrant, like it's in the bottom. Yeah, but then it's the same thing. You use the same method, just that now it's in the fourth quadrant. That's the only difference. Yeah. So, any other question before I can move to where is that calculator? Any other question? Okay. Um, you see, hey, these things they are too much. There's too much information to know here. It requires a lot of practice. This thing. So yeah, you can choose any example that we can do there. The exercise. Uh, because you are done with the examples, I think. So you can choose any exercise that you think is complex. I'm giving it to you that you think it's problematic. Okay, let me go to that. You see, we're gonna be done with this thing soon, like now. 2.9. Let me draw that. Wait. Wait, 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 wait. Let me draw that. 2.9. 2.9. It's something like this. This is the one. Eh? It's 20 LB, and then you've got this one. This one you know it, buff. This is a right angle triangle, and then you've got 20 there, 20 degrees right there. And then the question. Let me read the question. They say find the resultant. The resultant. Remember the resultant. It has to be between the. Ish. Okay. Oh, okay. There they are asking you to find R. Okay, you're gonna find that. It's easy. It's easy. Already, as you can see, we are given this thing. How do you find R buffer with this one? This is a right angle triangle. It's 90. Yeah, they told you that this is 90. So to find RT, it's Pythagoras theorem, isn't it? It's 20 squared plus 30 squared. The only difference is that is the angle. You see, this is your x-axis. I'll show you. It's easy. You know this. I know. I know that you know it. It's 20 squared uh, plus that. You're gonna get 36.1. Um, it's 20, 36.1, 36.055 or 36.1, 36.055 LB. Did you get that? And then now you have to find the angle as well. The angle from the x-axis to your R. Remember that angle that I told you about. Remember theta is always from x-axis to R. This is your R. Okay, let me do this. This is your RT. Then you need to find the angle from there to there. You see that angle, it includes 20 inside. So now, but then we cannot find that theta. Okay, we need to find theta. Let me write it in blue so that you can see that it's theta. Is that angle, the whole angle from there. Theta equals to 20 plus that beta. Let's write it as beta, that angle there, beta. So now it means we're going to have to find beta. To find beta, we're going to use tan. Tan beta equals to opposite over hypotenuse. Do you see that? Do you understand what I did? You see that theta from x-axis to rt. It includes that 20. But then we don't know that angle beta. That is inside the right angle triangle. So we need to find that angle beta. And then to find that angle beta, we need to use a tan because it's a right angle triangle. So we're going to say tan is equals to opposite. What is our opposite? From the from that thing, from the graph that I drew. What is opposite to beta? Okay, maybe let me draw it here. What is opposite to beta? Sure. Where is that arrow? Okay, 30 over adjacent. Yeah. Yeah, I get this is RT. So it cannot be adjacent to RT. So you're gonna say tan of okay, tan of 30 over 20. And then you're gonna get 56.3. 56.31. Okay, let's just say 31. So you're gonna go and say to find that theta, you're gonna add the two. You're gonna get 76.31. Do you see that? Yeah, 76.31. That's your angle. This is how you find it. Does it make sense, of? Yeah. It's not that difficult. This one. Then we're gonna do the last one because it's almost quarter two. We started at quarter two exactly. Let's see. Wait, the presentation will tell us. Wait. Let me do this. This will tell us. Okay, that's the recording. Yeah. So, any other question before? I hope whatever we did today it makes sense. Well, you see, we are done with chapter two already. Yeah, we are done with chapter two. So it means next time when we meet, me and you, we have to do if you have got any questions, we're gonna start with those questions from exercise from chapter two, and then we answer those. Then we move to chapter three. Then yeah, we should be done before. Like we're almost there, bro. Hey, at least it only takes us one and a half session to finish a chapter. Like it's one and a half basically. Because last week we finished off chapter one and then we started two. Then this week we finished off chapter 2. So next week we're gonna start chapter 3, and then we're gonna do the other half. Yeah, because it's impossible like to finish. Yeah, like we can't finish a chapter in one day. That's highly impossible. In 2 hours, that's highly impossible. We can't. It's 2 hours is too small to finish the whole chapter. Yeah, but at least with the examples that we did, we have a clue. Yeah, yeah, exactly. So if you've got any other questions, then we ask me, then we answer those questions quickly, then we move. We move. Otherwise, you don't have any question. Nothing for now. But for immediately after, okay, let me do this. Since you're saying there's no questions, let me do this before I forget. I have to